Section 5.3 example 4 says, what is the difference? 3 over d minus 1 minus 2 over d plus 2. Now notice d minus 1 and d plus 2 again are not common denominators, so we need to find the least common denominator. D minus 1 is as simplified as it will be, and so is d plus 2. D minus 1 and d plus 2 are not the same, they don't have anything in common. So this isn't like finding the prime factorization because we are dealing with a binomial. So if they have nothing in common, we multiply them together, and that is our common denominator. So that gives us a least common denominator of d minus 1 times d plus 2. So here, right now, we just have d minus 1. We need to multiply this top and bottom by d plus 2. And then on this one, we have just d plus 2, so we need to multiply the top and bottom by d minus 1. Now, since we are multiplying by a binomial, we need to distribute the constants that are up top. So we need to distribute the 3 to the d plus 2 and distribute the 2 to the d minus 1. When we distribute the 3, we get 3d plus 6. When we distribute the 2, we get 2d minus 2. Now we have a common denominator, and we can subtract our numerators. This gives us 3d plus 6 minus the whole thing in parentheses, 2d minus 2, because we do need to distribute that negative sign, all over d minus 1 times d plus 2. When we distribute the negative sign, we get 3d plus 6 minus 2d, and then minus a negative 2 gives us plus 2, again over d minus 1 times d plus 2. Now we want to look for some like terms. So notice we have a 3d and a negative 2d, and we also have a plus 6 and a plus 2. We have 3d minus 2d gives us d, and 6 plus 2 gives us 8, all over d minus 1 times d plus 2. These are all already as simplified as they can be, and none of them are in common on the top and bottom, so we have no common factors, and this is the final answer. All the work for this problem is on the next few slides. And now I would like you to subtract a over a plus 3 minus 4 over a plus 5.